Hi everyone, welcome back to the Comptia Network Plus course, High Availability. High availability is a system designed protocol that guarantees a certain amount of operational uptime during a given period. The design attempts to minimize unplanned downtime. Users are unable to access resources. In almost all cases, high availability is provided through the implementation of duplicate equipment, multiple servers, multiple NICs, etc. Organizations that serve critical functions obviously need this. After all, you really don't want to blaze your way to a hospital ER only to find out they can't treat you because their network is down. Caching engines. A cache is a collection of data that duplicates key pieces of original data. Computers use caches all the time to temporarily store information for faster access. And processors have both internal and external caches available to them, which speeds up their response times. A caching engine is basically a database on a server that stores information people need to access fast. The most popular implementation of this with web servers and proxy servers, but caching engines are also used on internal networks to speed up access to things like database services. Fault tolerance. Fault tolerant means that even if one component fails, you won't lose access to the resources it provides. To implement fault tolerance, you need to employ multiple devices or connections that all provide a way to access the same resources. A familiar form of fault tolerance is configuration an additional hard drive. In networking, fault tolerance means that you have multiple paths from one point to another. What's really cool is that fault tolerant connections can be configured to be available either on standby basis only or on all the time if you intend to use them as part of a load balancing system. Archive backups. While providing redundancy to hardware components is important, the data that resides on the components must also be archived in case a device where the data is stored has to be replaced. It could be a matter of replacing a hard drive on which the data cannot be saved and restoring the data from tape backup. Or suppose RAID has been enabled in a system. In that case, the loss of a single hard drive will not present an immediate loss to access of data, although replacement of the hard drive will be required to recover from another drive failure. RAID systems are covered in more detail in chapter 15, Physical Security and Risk. With regard to the data backups, they must be created on a schedule and tested regularly to ensure that a data restoration is successful. The three main data backup types are full backups, differential backups, and incremental backups. But to understand them, you must grasp the concept of archive bits. When a file is created or updated, the archive bit for the file is enabled. If the archive bit is cleared, the file will not be archived during the next backup. If the archive bit is enabled, the file will be archived during the next backup. The end result is that each type of backup differs in the amount of time taken. The amount of data backed up, whether unchanged data is backed up repeatedly, and the number of tapes required to restore the data. Keep these key facts in mind. If you use a full backup once a week and differential backups the other days of the week to restore, you will only need the last backup tape and the last differential tape. This is the fastest restore. If you use a full backup once a week and incremental backups the other days of the week to restore, you will need the last full backup tape and all incremental tapes. This is the slowest restore. A comparison of the three main types of the three main backup types is shown in figure 20.10. Backup type full. All data slowest, fastest, high. Incremental backup only new modified file folders fast, moderate, lowest. Differential backup all data since last backup moderate, fast, moderate. Common Address Redundancy Protocol. Common Address Redundancy Protocol CARP provides IP-based redundancy, allowing a group of hosts on the same network segment, referred to as a redundancy group, to share an IP address. One host is designated the master and the rest are backups. The master host responds to any traffic on ARP requests directed towards it. Each host may belong to more than one redundancy group at a time. One of its most common uses is to provide redundancy for devices such as firewalls and routers. The virtual IP address, this is another name for the shared group IP address, will be shared by the group of routers and firewalls. The client machines will use the virtual IP address as their default gateway. In the event that the master router suffers a failure or is taken offline, the IP will move to one of the backup routers and service will continue. Other protocols that use similar principles are Virtual Router Redundancy Protocol and Hot Standby Router Protocol. Virtual networking. Over the last few years, one of the most significant developments helping to increase the efficient use of computing resources, leading to an increase in network performance with an increase in spending on hardware, has been the widespread adoption of virtualization technology. You can't read an industry publication without coming across the term cloud computing within 45 seconds. The concept of virtualization is quite simple. Instead of dedicating a physical piece of hardware to every server, run multiple instances of every server operating system, each in its own virtual environment on the same physical piece of equipment. This saves power, maximizes the use of memory and CPU resources, and can even help hide the physical location for each virtual server. Virtual computing solutions come from a number of vendors. The following are some of the more popular currently: VMware, vSphere, Microsoft Hyper-V, Citrix, XenServer. All of these solutions work on the same basic concept, but each has its own unique feature and of course all claim to be the best solution. In the following section, I will discuss the building blocks of virtualization rather than the specific implementation from any single vendor. On-site versus off-site. Often you hear the terms public cloud and private cloud. Clouds can be thought of as virtual computing environments where virtual servers and desktops live and can be accessed by users. A private cloud is one in which this environment is provided to the enterprise by a third party for a fee. This is a good solution for a company that has neither the expertise nor the resources to manage their own cloud, yet would like to take advantage of the benefits that cloud computing offers: increased performance, increased fault tolerance, constant availability, access from anywhere. These type of clouds might be considered off-site or public. On the other hand, for the organization that has the expertise and resource, a private or on-site solution might be better and might be more secure. This approach will enjoy the same benefits as a public cloud and may offer more precise control and more options to the organization. Virtual networking components. The foundation of virtualization is the host device, which may be a workstation or a server. This device is the physical machine that contains the software that makes virtualization possible, and the containers or virtual machines for the guest operating systems. The host provides the underlying hardware and computing resources such as processing power, memory and hard disk I/O to the VMs. Each guest is a separate and independent instance of an operating system and the application software from a high level. The relationship is shown in figure 20.11. Virtualization can be deployed in several different ways to deliver cost-effective solutions to different problems. Each of the following components can have its place in the solution. So I'm going to here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.